Good day, students. You are welcome once again to today's lecture. This time around, I'll be doing this at home because see COVID-19. The federal government has urged all of us to stay back at home. I'm very sure you are doing the same. So let us take the advantage and learn from home. Today, I'll be taking you further mass the topic rate of change, application of differential calculus. So let's get down to business. Okay, rate of change, application of differential calculus. Now we have 3 questions to solve here. I'm going to take my time to explain how you should approach these questions. Like question number 1, it says a block of ice in the form of a cube with sides x cm melts at a rate of 9.72 cm cube per minute. Find the rate of change of x at the instant when x is 12 centimeter. Now, there is something you need to know before you start solving question on rate of change. Now, come with me to this small explanation. Now, we have, say, a function y is equal to f of x. Now, for us to calculate the rate of change of y with respect to x, say the y, the t, that will be t now because it's per time. So this is going to be the y over the x times the x over the t. Now, by implication, the right side, if you simplify this, you get the left side. So this is the manipulation we'll be doing anytime we're calculating the rate of change. Now, it could concern volume, the rate of change in volume with respect to r, is volume of a sphere, the volume of a circle. Now, there is something that always connects the volume and the radius. If you increase the radius, definitely the volume will increase. If you decrease the radius, definitely the volume will decrease. Or it could involve area. Area could be a function of L, as the length of the side of a square, a rectangle, and so on. So if you are finding the rate of change of the volume, that will be dv dt. It will simply be, you have to write dv here over then times dt. These are the two things that we know for sure. So what will be here and here has to do with the other variable r. So definitely it's going to be the r and the r. So this is how we have a link. Then for the area, if we want to find the rate of change in the area, that will be dA over dt. So this one will be equal to dA will be here times over dt. So what will be here and here has to do with the other variable as well. So this one will be dl and this one will be dl. So these are what you need to establish in any given question. So let's go to the question again and see how we'll solve it. So a block of ice in the form of a cube with side x cm melts at a rate of 9.72 cm cube per minute. Find the rate of change of x at the instant when x is 12 centimeter. So what you would do, first of all, a cube has been mentioned. The ice is in the form of a cube. So this is a cube. I want to sketch a cube. This is a cube. The size are x cm. So here is going to be x, x, and x. So volume now, talking about volume of a cube, that will be x times x times x. That will give you x cubed. I have established one relationship here, volume with respect to the side. And let's get the variables that we have in the question. It melts at a rate of 9.72 cm cube per minute. So this is the rate. This is a volume cm cube. So what it simply means is that we have been given the V, the T, to be 9.72 cm cube now per seconds. So from this equation, you can differentiate this equation, the V, the X, that would be 3x squared. Now, what are we looking for in the question? The question is asking us to find the rate of change of x. Rate of change of x. So it means dx dt is what we are looking for. So with this question, let us have a link. The x dt will now be dx over times dt. So what is going to be here is definitely going to be volume. That will be dv, and here will be dv. So, and we have our dv dx as 3x, but here we have dx dv. So dx dv, dv dx, it means if I want to get my dx dv, I will do the reciprocal. The x dv will now be 1 over 3x squared. So from this formula, we have this already, and we have dv dt. Our dv dt has been given. So dx dt will be 1 over 3x squared times 9.72. So this will be 1 over 3 times 12 squared, because x is 12 at the instant. If you check your question, at the instant when x is 12. So from here, now multiply by 9.72. So this is 9.72 over 3 times 144. If you compute your calculator very well, you have a value of 0.02. Let's say to 2 decimal place approximately. Now it is centimeter per seconds, since it is rate of change in the side with respect to time. So this is the solution to the question. Now you have to view this over and over to understand it with the question. You have to read the question and check out my solution. Now I don't want the size of this document to be too heavy, so I would like you to have the question. I'm going to snap it, read it, check my procedure, then attempt number 2 by tomorrow. I will solve number 2 and number 3. Can go over the solution.
What a friend we have in Jesus, all our sins and griefs to bear. What a privilege to carry everything to God in prayer.
I will be there to attend to you. Okay, student, thank you for listening. I hope the solution is well explained enough to help you solve other related questions. I'll be back to solve number 2 and number 3 probably next class. Thank you. Enjoy your stay.
What a friend we have in Jesus, all our sins and griefs to bear.